everyone, how's your day? Today, our lesson is all about heat and temperature. What do you think is the difference between the two? Let's find out as we finish this video. Most essential learning competency. Differentiate between heat and temperature at the molecular level. Our objectives are define heat, define temperature, differentiate between heat and temperature at the molecular level, explain the effects of heat on the body, relate heat to mass and temperature through the concept of specific heat capacity, and calculate the heat absorbed or released to raise or decrease the temperature of a substance. Let us first try this experiment. The materials we need for this experiment are spoon, glass, and hot water. Procedure number 1. Fill the glass with hot water. Number 2. Feel the temperature of the spoon. Is it hot, normal, or cold? Number 3. Put the spoon in the glass with hot water. Number 4. After few minutes, remove the spoon from the glass and fill it again. Is it hot, normal, or cold? Why do you think so? Heat refers to the process by which energy is transferred between objects because of the difference in their temperatures. It tends to move from an object at a higher temperature to an object at a lower temperature. In our experiment a while ago, since the hot water has the higher temperature compared to the spoon, the heat transfers from the hot water to the spoon, making the spoon to become hotter compared to its original temperature. Temperature is the measure of the average kinetic energy per molecule in a substance. It can be measured in degrees Celsius, Fahrenheit, or Kelvin. Atoms and molecules in solid are in fixed position, vibrating back and forth, very close together, and have strong bonds between them. Atoms and molecules in liquid are close together. It can move past each other and have weak bonds between them. Atoms and molecules in gas are far apart. It can move past each other and have almost no bonds between them. Matter is made up of continuously moving atoms or molecules. Due to this random motion, the atoms and molecules in a matter have kinetic energy. When you touch a hot object, you feel a sensation of pain. This pain is related to the speed of particles in the hot object. It is observed that particles in hot object move faster than those in cold object. When objects absorb heat, the molecules have the tendency to expand, and when objects are cooled or released heat, the molecules contracts. If you're going to heat water and oil in a separate pan, what substance will boil first? Is it the water, the oil, or they will boil at the same time? Very good! The answer is the oil. The oil has less specific heat capacity compared to water. Therefore, it raises its temperature faster than the water. Specific heat capacity is the measure of the amount of energy needed to change a substance temperature. If you're going to put a cup of water in a basin filled with water outside the house where it receives direct heat from the sun, which do you think will be warmer after 4 hours? Which of the two will likely have more evaporation once exposed in the sun? Is it the cup of water or the basin filled with water? Very good! The answer is the cup of water. Since the volume of water in the cup is lesser than the basin, it needs less heat to become warmer or to evaporate, unlike in the basin of water, where it has higher volume that needs more heat to become warm or to evaporate. The higher the mass of an object, the higher amount of heat it can absorb to change the temperature of that object. The lower the mass, the lower amount of heat it can absorb to change the temperature of that object. Heat capacity is the amount of heat required to raise the temperature of an object or substance to 1 degree Celsius. It is dependent to the mass of an object. It has a formula of heat capacity is equal to the mass of an object times the specific heat capacity times the change in temperature of an object. Sample problem. Calculate the energy needed to raise the temperature of 1 gram of water from 0 degrees Celsius to 10 degrees Celsius. The water has 4.18 joule per gram degrees Celsius specific heat capacity. Step 1. Find the given. In our problem, we have mass is equal to 1 gram, specific heat capacity is equal to 4.18 joule per gram degrees Celsius. Our initial temperature is 0 degrees Celsius and our final temperature is 10 degrees Celsius. So the missing in our problem is the heat capacity. Step 2. Write the equation. The equation for our problem will be heat capacity is equal to the mass times the specific heat capacity times the difference of the final temperature and the initial temperature. Step 3. Substitute the formula with the given. For our solution, we have heat capacity is equal to 1 gram times 4.18 joule per gram degree Celsius times the difference in the temperature, which is 10 degrees Celsius. Step 4. Write your final answer. So the answer will be heat capacity is equal to 41.84 joules. That's it for the day. Thank you very much for watching. See you next week. Bye-bye.
Thanks to subscribe.